This is an old demo invented by the American electrical engineer Elihuthomson. And basically it consists of a coil of wire in which we're going to put an alternating current. And that is going to cause a changing magnetic field, which is going to be carried in this iron insert here. And we're going to put various rings over the top of it. And I want you to see what happens. Alright, so we have a aluminum ring over the iron core, and we'll just connect the current briefly. We can do it with some copper. Do it with a lighter piece of copper that's also taller. Do it with a piece of aluminum foil. One last piece of aluminum. And then finally this piece of aluminum with a break in it. Nothing. Let's talk about why. So what's going on with the Thomson apparatus? Basically, because of the current in this solenoid, we're creating a magnetic field, which will point up and down. It actually reverses its direction 60 times every second because it's hooked up to the wall AC current. And that leads to something interesting, because if you have a changing magnetic field and you enclose it in a conductor, cause there to be magnetic flux inside the conductor, a changing magnetic field will then create a new current. It's exactly what we saw when we dropped the magnets through the copper tube. So basically, we have a current in the original coil, causes a magnetic field in the iron core here, which causes a new current in the aluminum ring. And it's the interaction between those two currents that cause the repulsion. The physics of this is actually somewhat complex, and I've got a link to a paper on the Flickr version of this video by Matos and Silva and Desena that really go through the details if you're interested. But it's another great example of an induced current, and the way it interacts with the current that caused the magnetic field that caused it is pretty dramatic.